We are here. Hi, everyone. Welcome. I can see a lot of different people coming. Perfect. Hi, Thomas. How are you? 1 second so everyone can be connected. Welcome, everyone. How are you? How are you there? Welcome to everyone to this new call that we are hosting today with Anthony, this webinar. Hi, Anthony. How are you?
I'm fine. How are you, Sophia?
Fine, thank you. Tell us in the chat, everyone, please, where are you joining us? We always want to know where is our community right now. We want to share our thoughts and our community cultures, so it's very important for us. I can see here Barcelona. I'm in Barcelona too. Hello, Paras. Of course, we will share the recording also, so don't worry about it. And where are you right now, Anthony? Tell us.
I actually just flew into Uganda this morning.
Amazing.
So I'm still getting settled in, but I'm happy to be here and just to chat about this with everyone.
Of course. Well, thank you very much for your time here, for share with the community your thoughts and so on. First of all, a couple of things to have into account before the starting of the webinar. We have 30 minutes of presentation that Anthony will be sharing with all of us. And then we have a space of 15 minutes, 20 for a Q&A session. Remember that you can also write the questions that you have during the webinar into the chat or Q&A, or I will also share with you guys the platform engineering Slack, so you can also ask their questions and join the community if you still, if you didn't join yet. So it's amazing because we can like talk there and know how is our community. So I can see, Anthony, perfectly your screen. If you want to start, please let us know. I will stop my
Okay, I can start. What do you see? Do you see a blue screen? Just making sure I'm sharing.
Yeah, it's perfect.
Okay, so I can get started. So thanks again, Sophia. So hi everyone. Thanks for joining in to have this conversation and have this chat today. So my name is Anthony Alaribe. I'm based out of Berlin, where I run a company called API Toolkit. But today I want to talk about how to accidentally lose 2 million or more than $2 million to API breaking changes, or how to prevent it. The title is pretty much clickbaity, honestly. Yeah, so don't judge me for that. But and it's clickbaity because even though we have this dollar value in the title, I'm hoping that the conversation is more focused on how to prevent it than how to lose. So you don't need to build up practice on how to lose money. But anyway, let's just get right in. Yeah. Yeah, so let's backtrack. So I used to work for this company. I hope you can see the front of the Delivery Hero headquarters in Berlin. So I used to work at this company in Berlin in between 2018 and 2022. So at the time that I joined, they were going really fast in a sense that they were acquiring a lot of brands around the world. So you see a picture of like some of the acquisitions. So between that 2018 to or 2017 to 2022 was when most of the acquisitions happened. And a lot of these acquisitions were actually brands that were in Asia. And if you know anything about the Asian market, sometimes launching in one Asian city can be equivalent to getting an extra 10 million customers really overnight. So, things would usually break, things would usually go down around the peak times. So Delivery Hero is this brand of brands of food delivery brands. So brands like Glovo, Food Panda, Talabat, Foodora, onlinepizza.de, .se, etc. are some of the brands that are under the Delivery Hero umbrella. So that means that you can imagine when people usually order food, dinner time, lunchtime, and our peak time would usually be lunchtime on Sundays, and things would usually go down. So on a Sunday, where everyone would be like afraid, staying very close to their computers, because if things crash, then we have to, get in and try to fix whatever has broken. And this was not a very good way you want to run a company. So we started to think about what should we do? How can we make things better? How can we make the systems more robust? So, remember, we're still acquiring lots of brands and expanding into new markets. So this growth was actually expected to even go 5x or even 10x that the number we were at the time. So we decided that we're going to rewrite some of the very critical hot parts from PHP. This legacy system was a monolith written in PHP, and we wanted to rewrite it in Go, which is, I mean, it's a good stack, it's a good decision-ish. But anyone who has actually done such a rewrite knows that it always seems easier in the beginning than it actually is in reality. I'm having a bit of a brain freeze. Yeah, so what do you do when you're doing such a rewrite? So the first thing that we did is study the code and API specifications. I'm laughing because the API specification did not exist. Or it actually existed in a sense that there was this document, this YAML, either YAML or JSON documents that represented the specification, and developers would have to manually update it when they add new fields. So you can imagine how much this document, this specification deviated so much from the actual system in production. This is the system that was in production for more than a decade. And the code was also very difficult to study because remember, it's a PHP monolith, and PHP is a lovely language. The challenge with it being a dynamic language is that sometimes it's not very clear what are all the responses, what are all the fields that a particular endpoint would return, because it could be injected in from like many random points. It could even be injected by a library that is in some GitHub repository somewhere else, right? So it was very difficult to track what was going on and what was the expected behavior of the system that we wanted to rewrite in Go. So what did we do? Of course, we can't just give up just because of how hard the problem is. So we started to explore what we could do that would let us like understand, first of all, the legacy system, and then just gradually replace it with a new system. So we did this by building a proxy service in Go. So a proxy is basically almost like a middleware, but a middleware service that sits in front of another service, and all the requests go through your proxy service. And this proxy service would accept the traffic, make a request to the legacy system, and then in the beginning to just return it. But in the long run, we would start to rewrite the logic and then use a feature flag to decide whether the request goes to the new service or to the legacy service. So this is how you would implement such a proxy in Go. I'm using Go because that was the language we wrote into, and it was actually a good. Go is actually a very good tool for this sort of proxies because they literally have a function for doing this in the standard library, this new single host reverse proxy function, the HTTP util package. And this function is amazing because, we could, it could basically record the traffic we are sending to the legacy. And then what we did is that at some point we would send traffic to the legacy system, but also call our own custom logic, which is supposed to replace the legacy system. And then we can compare the responses from the legacy with our own system to make sure that, what we've built is actually pretty much exactly what this legacy system does. So this was, in my opinion, I think not so bad a solution. The only challenge is that we couldn't really just roll this out in production. So we're mostly testing it in like staging environments and smaller environments. So we test it in we pick like a country to test at a time, just very small groups. Unfortunately, and I mean, obviously, this screenshot that I just showed you is a very simplified version of a proxy because you can see a lot of things that are not happening there. For example, we're not even copying the headers in that code example I showed you. But the code is just to show you the principle. But before I go into the problems with that proxy, it wasn't really enough. But we also found that when we make a request to the legacy systems and then make a request to our own logic, and those two responses are not the same, we could log the JSON responses, go to some of these tools like JSON diff or semantic diff, and compare them just to find out what is different between both of them. And I mean, this is a good strategy, but was it enough? Unfortunately, I would like to say it was enough, but it really wasn't. And it wasn't, if it was enough, we would not have this clickbaity title of us losing over $2 million worth of orders. But basically, when we ran this in staging for some time, we got this false sense of security that the responses from the legacy and the responses from our new system were pretty much equivalent. And so we're like, okay, roll this out into production. And when we did that, we had the downtime. It wasn't really downtime, but we had the incident. And the incident was a very simple thing. One field was missing. Basically, in some countries, especially in the Scandinavian countries, there is a legal requirement that these brands have to return, food delivery brands have to return the allergy information of every dish. Now, most countries don't have this requirement. So we're mostly testing, and this is the brand Delivery Hero operated at the time operated in more than 55 countries. So we had to cherry pick and test in some of these countries. So some countries had this legal requirement that you need to include dietary requirements and all of this stuff, but most countries did not have this, and we're testing in the countries that did not have these requirements. So when we rolled it out, in those particular countries, everything crashed. We had to spend time figuring out what was wrong. We rolled back, figured out, but we had lost some money already. It was a very difficult issue to debug because when someone says, "Oh, something is wrong," you go to I would go to like Food Panda Singapore and see, everything is looking very fine. But it was not fine because in some of the countries, this issue was still happening. But in any case, what could we have done better? This is a very important question because we had a lot of retrospectives thinking about how we could have made this better. And unfortunately, you can only connect the dots looking backwards. So it's easy to sit down from 2024 and say, we should have done this and this and this. And I have a lot of ideas of things we could have done better. But unfortunately, we didn't do those things. So we started to think in those retrospectives, what could we have really outside of a simple thing like, oh, you should have tested in all 55 countries. How could we have automated catching these kind of issues? Breaking changes where the response from a service is different from what it used to look like. Or even just the main problem. Why we even had this problem in the first place was that we did not have an open API specification that was up to date. And so some ideas were, what if we could actually learn this schema from the live traffic? That way the schema is always up to date. Some other thoughts that we started to ask during the retrospectives were, were thoughts like, what if we could pick out this live traffic? So remember, we had an issue where there was no dietary requirement. What if we had maybe passed this data, this request and response data through, let's just, we're in 2024, where it's the age of machine learning or artificial intelligence. But let's say, what if we could take that traffic, put it into a model, and that model could learn the patterns of each of these endpoints and then tell us that, okay, now the requests that are coming in or the responses that are coming in from this particular endpoint look differently from how they used to look a week ago. You know, if we had something like this, we would not have had that issue, because in our new, after our deployment, one field was basically missing. And such a system could have noticed and told us that, oh, this field, allergy, is missing and it's supposed to be there, or it's usually there 20% of the time, but now it's there 0% of the time. But in very strong words, we realized that, yeah, just monitoring status codes is not enough. And we had very sophisticated, I'm kind of winking, but we had these sophisticated monitoring systems, specifically Datadog and Neuralink, which we were using and actually paid a lot of money for, honestly. But what these guys really do is that you give them some information, for example, the status codes and maybe the endpoint names, and then you can create monitors and alerts. For example, if the status codes, if you're getting too many 400s or 500 status codes, then that counts as an error. And if the error rate is too high, send an alert to someone. So that's really what a lot of these tools are good for in terms of monitoring real production web services. And we felt like this was not enough. A lot of the issues, for example, in this particular incident, the endpoints were returning responses, they were returning status 200, which means none of those tools were able to catch or identify any problem. Okay, you might have noticed that I'm talking about live traffic a lot in these check items. So let's backtrack. So at the point where we're growing very fast, we also realized that we needed to do load tests to see basically what resources we need to handle the next level of the traffic. We need to be able to make sure that our servers and our systems can always handle 2-3x of production of the last peak production traffic. So we did this load test, this huge load test, and we found out that every time we had code a load test with locust or K6, if you've heard of any of those, the load tests were not really catching much, because the cache, for example, would take the data that you're querying a lot and put hot state or hot cache, which means if you're requesting the same data all the time, you think, oh, my system can handle this amount of traffic, but in reality, they can't. They're handling that amount of traffic because it's the same data you're asking for constantly. So what did we do? We recorded production traffic. So just stored it, just went into our monitoring tool, logged everything, and then downloaded it. And what we would do is we play this production traffic against the servers, but maybe 3x of that production. And that gave us more realistic load test situations. So we already started to build this, we already had this culture of recording and keeping a log of the production traffic. So what if we reuse this data for a lot of those points that we're looking at on the slide, answering those questions using this real life data that we already recorded for the load test. So the load test would usually be that you store everything and you replay it 3x against using something like K6 or locust. Okay. So now we've recorded this traffic and we've decided that we want to use the real data for our monitoring purposes. We want to monitor not just status 500. We want to monitor if our system is really working. If an endpoint that should return a real list of data, maybe a list of users, is returning an empty list, even though the status code is 200, someone should be alerted that something is wrong. So how do we do this? So first thing, let's look at a quick example. So this is a bunch of requests. Notice that we have some requests that have the detail and the name, John Doe or Romeo Doe or whatever, and then the age, while some of the requests don't have an age. So how do we process all of these requests in a way that can be analyzed for our monitoring purposes? So first of all, we can flatten it, right? So this is an example of how you'd flatten. Very simple algorithm. Actually, this is an example of such an algorithm for flattening JSON in Go. So it's just recursive, but you can take the JSON and flatten it into this list of key value pairs. Now, this gives us data that is a bit easier to computationally reason about. So what next? What if we take all the keys, ignore the values for now. So we take all the keys and we hash the keys, right? So this is an XX hash 32 algorithm, one of the fastest hashing algorithms out there in the world. I think there's some faster ones now, but it's one of the fast ones. So what if we hash these keys? .detail.names hash is 254 whatever, and .ages hash is CEA whatever. So now we have this bunch of hashes, which is fixed length. It's like a small amount of data that you can store in your database, or you can keep it in memory because it's a small amount of data. Now, what if we take these two and we add them together and maybe hash it again? Now we have one hash, which is basically a Merkle root, if you're aware of Merkle trees, that represents this particular response, or at least the fields of the response, which means, I'm sorry, if we in the previous list, okay, I think I mentioned here that you can sort it before you hash it. But yeah, which means if we had some responses that have age, and then some responses that do not have age, just to show what I mean, look at this. Remember that in this example, some had the age and some did not have the age. So if we compress those into the hashes, we end up with just a bunch of different hashes that together represent all the possible combinations of responses of these particular endpoints. That means you've unlocked a lot of possibilities. If every response that comes in, you hash it the way we did right now, and you get out the hash, you can easily check if that hash is within the list of the hashes that are possible for this particular endpoint. And what does that mean? If you get a new hash that was not in the original list, it means that in that particular endpoint, a new field has probably been introduced. Likewise, if you know that you have, if a field was deleted, likewise, if a field was deleted, you would equally have a new hash, which means, there's probably a breaking change that you can analyze. And this is a calculation that you can do at scale, because now you don't really have to, really go into all the responses and do a lot of calculations or checking the database to see what is what. You're just processing it into a very small hash using a very fast hashing algorithm. And you can do that 1 million times per minute, assuming your server is doing 1 million requests per minute. And so imagine we add a new field, error, for example. Because error has a new hash, it means that we've added a new hash to the set of possible shapes of this get/endpoint, right? Here's just a screenshot of what a Merkle tree is. A Merkle tree is just a hash of hashes, and hash is just kind of like a binary tree, but hashes all the way down. Right? Anyway, why does this matter? So we can store every single field in a database, and on every request, we can hit the database to see if that field exists already. But imagine if in a platform that is handling millions of requests per second, you probably don't want to hit the database every single time. So with this hashing thing, we can easily, because we've reduced the REST API into just a bunch of hashes, we can keep those hashes in memory and then perform those checks in memory. And if you want to go crazy, you can introduce something like a Bloom filter to keep some of those values if you want to just be a bit more memory compact. For example, if you have a lot of fields that you're processing. Here is just a small image of how a Bloom filter works. I don't want to go into the explanation, but you can do a quick Google just based on time. But the point of this entire talk is this, by analyzing this request, this actual raw request data, we're able to start to catch a lot of issues that before would make us lose money. But it also opened new possibilities. For example, I already mentioned that we're able to do more realistic load tests by just having this bunch of data. But we're also able to take this data, this list of hashes. Please give me a second. I'm in a place that still has blackouts. But we're able to take this list of hashes and then process it into an open API specification, for example, and even go many steps further by comparing all those requests that are coming in with the specification that we're able to generate, in order to catch like bugs or deviations from the specification, new field breaking changes, etc. All right. And we also found that one common use case that we started to do was that we would create this sort of alert. We kind of automated this, so we automatically collect the logs and pass it through these algorithms. So we could create this sort of alerts that, if a third-party service that we're using, so we're also logging the requests and responses to load third-party service. But if any of these third-party services deletes a field or returns a field with a different type, for example, if you had a string field which used to be a UUID and now it's no longer a UUID, then we can alert the team. I didn't show you how we do that for values, but those are some of the problems we started to solve by just analyzing the data at scale, right? So I guess that is really more or less the end of my talk. We did this between 2018 and 2022. And then I set out to, condense some of these learnings into a rethink of how observability should be. For example, why are we just monitoring status codes? Why are we not tracking the real issues that matter? For example, if there is if a third-party integration you have decides to make breaking changes, why don't we have tools that can alert you very quickly and tell you exactly what breaking changes they did, maybe even allow you explore what exact requests you made to them and what did they send back, for your debugging purposes. So all of that are condensed into a platform called API Toolkit. If you find this topic interesting and find what we're doing interesting, don't hesitate to just give me a shout out. These are some of the other things that we're doing on API Toolkit. So things like error tracking and application logs and traces and multi-step API tests. But yeah, that's the end of my talk, everybody. And yeah, feel free to shoot any questions that you might have.
Thanks, Anthony, for your information and your valuable content. Honestly, it was amazing, the presentation. I don't see any question, at least for now, in the chat or in the Q&A or also in the Slack channel. Please don't be shy. If anyone has any question to Anthony, this is the time to do it. He's here for us to share their thoughts and also the content. So we can have like at least 1 minute if someone needs to know something else, just in case.
Yes.
No one? Are you sure? Well, I think that your
Everyone is
information
shy
was very
today.
clear, Anthony. I think it was very clear that no one is asking, but if that's the case, this will be all for today. Remember, everyone, because there are some people that is asking on the chat, we will share again this presentation tomorrow and also the recording. Anthony will send it to me and I will send it to the whole of the people. Actually, we started to get some questions, Anthony. I saw you reading. So one is from Sanctual. He says, using hash in smart and interesting idea. Do you hash the request body, query param, and path params?
Yes. Remember, we don't hash the entire body, but we first of all normalize it. So we flatten it into this. Let me just go back in the slides. So we flatten the body into this key value, like this .detail, .name, for example, and then sort it and then hash and sort. Yeah. But yeah, we do that for also query parameters and path parameters. And the whole idea is that, we want to track any changes over time.
Okay, perfect. I don't know, Sanctuary, if you have any other question regarding this point. If not, like, That's the response from Anthony. But yeah, if we don't have any other question, please join us into the Slack channel also if you want to share with us something, or also you can write there like directly to Anthony if you think that you have any other question in these days that you suddenly need to know something. It's the perfect time and also channel to do it. Thank you again, Anthony, for your time here with the whole of the community. For us, it's very, very important. And thank you all for being here with us today. Remember that we have another webinars, workshops, and so on starting from next week. So if you also want to join us in another one, it's the perfect time to do it. You can find everything on the web, and also like we send a couple of emails. So if you receive it and it's on your interest, you can join us also. And that's it for today. Thanks, Anthony, and bye-bye, everyone.
Thanks, Sophia. Bye, everyone.